Welcome everybody to Blacoh and Sepro and talking about pulsation dampeners and peristaltic pumps and what a perfect match they are. Just a reminder, if you have any questions, if you will type them in the chat, we'll get to them probably at the end. Markus and Hercules plan on leaving us time so we can have some great interaction and questions. You type them in there and we'll make sure that they get to them. And then also we will be sending out a PDF version of this as soon as the webinar is complete. And if you need a certificate for your PE credits, that will also come in an email to you. So with that, I would like to introduce Markus Hillman. He has been with Blacoh Industries for 18 years, just a wealth of knowledge on pump applications as well as the benefits of pulsation dampeners to those pumping systems, and just always a wealth of information. So if you get an opportunity to talk to Markus ever, I encourage you to do so. And then we have Hercules Strydom from Sepro Mineral Systems. And Hercules is our expert on peristaltic or hose pumps, if you prefer. He's the product manager for Sepro and their hose pumps, and he's going to be walking us through. So if you're thinking about getting a hose pump, if you have one and it's not performing the way you'd like, he's our expert, and he's here to explain all of the ins and outs on these pumps. So today we're going to talk through peristaltic pumps, what the major components are, how they work, where and why you would use one, why you would want a pulsation dampener with one of those, some real life stories of how pulsation dampeners and peristaltic pumps work together, a quick summary, and then we'll have lots of time for Q&A. With that, I'm going to turn control over to Hercules so he can talk you through. Thank you.
Great stuff. Let me just see that I have control. Get back over here. Yes. All right, everybody. Thank you very much for joining us and taking time of your day to listen to us, and hopefully there's a bit of information you guys can contain and take forward with you to use in your everyday needs. Yeah, firstly, let's have a look and an overview as exactly what peristaltic pump is. A lot of people may have heard about it, but let's just have a look at where it comes from and what exactly the operating principles are. I mean, if we look at the animation that's running on the screen here, you will see that the original word peristaltic is derived from peristalsis. It's a common action that happens in everybody's body every day, contraction and relaxation of muscles in the body, peristalsis. So this was applied to a pumping principle in everyday use, which is actually a great little thing that we have been able to put down into the real world. Let's see what's on the next slide. So yes, the pump itself, as you can see, is a pretty basic and simple mechanism. It's a rubber hose contained inside a casing, and you have a roller or a shoe that is essentially squeezing the hose and turning inside the casing, trapping product inside a rubber hose. In front of the roller, there's a positive pressure pushing the product downstream, and behind the roller, you can see that the hose is expanding and drawing new product into the pump. Now the pump can be reversed if suction and discharge ports, top and bottom, doesn't matter. So yeah, it's a very basic piece of equipment, but does so much when it comes to actually the work that it does. Let's have a quick look at where they operate and what they do. As you can see on the screen there's quite a few industries involved that makes use of them. Top left there, battery production. This is something that's come up more recently in industry. It's a more newer industry in the world globally. Food and beverage, water and wastewater treatment, oil and gas, environmental remediation, construction, and mining industry. Mining industry is a large industry, but funny enough, it's not the largest one that makes use of peristaltic pumps. Actually, the medical and pharmaceutical industry is actually the ones that makes use of the highest amount of peristaltic pumps. But looking at all these industries, and if we look at the common denominators that is used, or where these pumps are applied in all of these industries, and essentially this brings us to the areas of applications that's found in all of these industries where the pumps feature best. If we look at corrosive liquids and slurries, any of these industries that has corrosive liquids or slurries, where you want the product being pumped to be isolated from the rest of the pumping components due to either temperature or just corrosion ability of the product being pumped, you want to use a peristaltic pump there. If you're looking at solid concentrations between 40 and 80%, that's where the peristaltic pump essentially takes over from a centrifugal pump, where a centrifugal pump would then be struggling to work efficiently and function efficiently. The peristaltic pump takes over at about 40% to 80% solids. So high solid concentration applications. This would be the first ones, and probably important ones that comes to mind would be thickened slurries or thickener underflow in the mining industries, concentrate transfer. In the mining industries, if you look at shear sensitive materials, these are, if you look at the obvious ones, at water and wastewater treatment industries, where there's flocculant dosing into those applications. We know that flocculant strands are shear sensitive. Centrifugal pumps are not good for those applications. Peristaltic pumps are very low shear, applying on the product being pumped, so those are perfect to transfer flocculant and polymer enhanced slurries. Highly viscous materials, food and beverage industries are probably the first one that comes to mind. If we're looking at fruit concentrates, sauces, chocolates, anything that has got a high viscosity, that would definitely not be able to be transferred with a centrifugal pump. Peristaltic pump is the one to go. Even when you look at adhesives industries, we recently did supplied a pump to a company that were transferring 25 centipoise of a product of adhesive manufacturing facility. So even in adhesives industry, that the peristaltic pumps works pretty well. Last one, when it comes to features of the peristaltic pump, products which need to be metered, and this is probably what the peristaltic pump is best known for, is where we need to meter specific amounts of product and liquids into a system and a process, because we know the volume that's captured between the two rollers or shoes. We know that every rotation delivers a certain amount of product or chemical into a system. Metering of products is a very, very big application for these peristaltic pumps, and where they work pretty well, seeing that the hose and tubes inside the pumps are able to repeat the same transfer and flow rate for about 90 to 95% of a tube or hose life. So the hose pumps work pretty well in those applications. Yeah, let's have a look at just some common components of the peristaltic pump. If you look here on the screen, you can see that it's a basic mechanical piece of equipment. You got a housing, you got a rotor that's rotating inside a casing. You have roller or shoes that's compressing on the hose, which is essentially what's creating the positive displacement effect, because the hose is squeezed shut. The suction and the discharge is completely isolated from each other, and so whatever is in front of the roller, if you're looking at the discharge ports at the bottom, what's in front of the roller is what is being pushed downward, down the stream, positive pressure. Behind the roller, you're creating a suction as the hose is expanding, and you're drawing a new product into the hose. So yeah, any talented machine designer will be able to design a peristaltic pump mechanically, from a fabrication, machining, casted point of view, all the fabricated components. But a very important point when it comes to peristaltic pumps is the rubber hose that's inside this pump. Probably around 50% of the technology and the focus is on the hose itself. It's a very, very niche and specialized piece of equipment, this hose. years and years and years of research and development that goes into these hoses that are very different from the everyday standard slurry transfer hoses, because this hose needs to be compressed and withstand loads and forces very high. The hose needs to survive for what is known to be, like, let's say 5 million compressions before it needs to be changed out. So do not be surprised or fooled about how much technology lies into in this rubber hose. Let's have a look. All right, next slide. Markus, I think this is one that you add some comments on.
Yeah, so thank you, Hercules. I appreciate that. So what you're looking at here is the undampened and dampened curve for a peristaltic pump. And if you look at the left side here and you see the drastic peak to peak pulsation curve. So if you were to draw a straight line through there, you're going to get a high peak and a low peak on that pulsation curve. Okay, so what is pulsation, right? So a pulsation is a sinusoidal wave of pressure, okay, that's being created each stroke of the pump. So each time, as Hercules said, that roller rolls over that hose, it is emitting that slug of pressure into the system, and that's where you get that peak to peak. So it becomes a very high amplitude pulse, but in a very low frequency. Why is that important? Well, as Hercules said earlier, when you're dealing with metering and you're metering, say, a chemical going through a line, that peak to peak could affect your flow meters and any downstream instrumentation, so you can't accurately decide how to dose a certain chemical. Also, this big, huge, drastic peak to peak curve also could cause a lot of damage on downstream equipment. Pipes can come loose, elbows can come loose, you could get leaks, you could damage valves, damage instrumentation. So what we're trying to do is we're trying to create an environment with a pulsation dampener where you have the right side here where you have a dampened curve, okay? And that what we do is we're removing that peak to peak, and we're trying to get as close to a mean line, a straight line, as possible. And we do that by three keys, and those three keys are an acronym called SLC, which we consider to be size, location, and charge. So when we're sizing a pulsation dampener for a hose pump or a peristaltic pump, we size that based on gallons per revolution. So as you saw in the previous screen where the roller was rolling over that hose and pinching that amount of fluid going through there, that's going to be your gallons per revolution. So that's how you would size a dampener, based on that gallons per revolution. Now, when you locate a dampener, we always locate the pulsation dampener as close to the pump as possible. We always suggest within 10 pipe diameters. Why is that important? Well, if you see the pulsation on the left coming out of the pump is very drastic. So if you have the dampener located, say you have a 2-inch pump and you're supposed to be within 20 pipe diameters of that, and you're downstream 4, 5, 6 feet, those huge pulsation curves are already getting into the system, and that limits the dampener's effectiveness downstream. So we want to make sure that dampener is located within 10 pipe diameters, as close to the discharge line, off the discharge line, eliminating any risers or elbows, close to the pump as possible. Thirdly, and probably the most important part of SLC, is the charging. Okay, we always suggest charging the dampener to at least 80% of your operating pressure. That's very important, because an undersized or undercharged dampener would cause the bladder to flex a little too much and might pull and stress the bladder and actually fail the bladder. Plus, your dampening effect would be very little. On the same side, on the reverse side of that, if we have less of a charge, if we have too much charge in the dampener, okay, then the bladder is just pushed down against the bottom of the dampener, and basically it's out of service. It's not going to do anything for you. So we want to make sure you're creating a low pressure area so that pulse can go into that dampener and that bladder can flex against compressed air nitrogen. And we suggest that to be around 80% of your operating pressure. On the next slide, you're going to see how the actual hose pump works. You'll see it, and because the case is clear, and you'll watch the gauge, and you'll see that left side of that graph where that peak to peak pulsation is happening, and what happens when a dampener is in service.
Pulsation dampening demonstration, we're using a peristaltic pump, also called a hose pump. It's called a hose pump because inside the case there is a hose and the pumping action is derived by using either 1, 2, or 3 roller shoes. For this video, we have removed the front of the hose pump to provide a better view of the hose and roller shoes. At the pump inlet, a roller shoe squeezes the hose, trapping liquid in the tube ahead of it. As the roller shoe rotates, liquid is pushed out of the pump's discharge. When the roller shoe releases the hose, after discharge, a momentary void or pocket is created where there is no product. This creates a partial vacuum as some product is actually sucked back to the discharge momentarily. This action, along with the normal pulsing action created by its positive displacement nature, makes the peristaltic pump very difficult to dampen the discharge flow. You will notice that the flow is pulsing as it comes out the discharge and that there is a very large swing in pressure on the pressure gauge. The flow actually stops at every rotation of a roller shoe. As we activate the dampener by opening an isolation valve, you'll notice that instantly the flow becomes steady and smooth, centrifugal-like, and that the needle on the pressure gauge is nearly stabilized, indicating that there are no more pressure swings, thus protecting piping and other system components. And again, as we deactivate the dampener, you will see the pulsation and the wide variation in pressure. Activating the dampener again immediately smooths the flow and eliminates the wild pressure swings. While the inlet stabilizer is not pictured in this demonstration, the same pressure and pulse action occurs at the pump's inlet. As a roller shoe passes across the pump inlet and closes it off, flow into the pump will momentarily stop. If the pump inlet is under positive pressure, acceleration head will cause a pressure spike and vibration, causing potential damage to pipe and components. If the pump inlet is under vacuum, cavitation and pump starvation can occur. These situations can be eliminated or minimized by the installation of Blacoh inlet stabilizers. Pump hose life may be extended and pipe and other components will be protected.
Yeah, so if you're looking at a pump system, as you can see from that video, you can see the drastic difference. You can see the pulsation curve that we looked at on the left side of the previous screen where you had that deep, you had those large peak-to-peak pulsations. And then as we dampened the flow, you saw the dampener come into that smooth laminar flow, which was on the right side of that graph. And that's what you're looking for, and that's what you want. And that's how you kind of create that centrifugal motion on your piping system. And that's going to protect all your downstream equipment. So what are some of the other items that you can see on that would be on a peristaltic system? Obviously, the pulsation dampener on the discharge. On smaller type hose pumps that are used for really acute dosing, you might use a back pressure valve. And a back pressure valve helps to create a constant back pressure, so your pump is always pumping against a constant back pressure. That also allows your dampener to be set more easily. You might have a pressure relief valve in case you block in pressure and you want to relieve that pressure on the system, so the pressure relief valve might be needed. As the video said, we talked about the inlet side where you might have some starvation of the pump. You could possibly install an inlet stabilizer also. I've seen a lot of peristaltic pump applications in the field where they have both a discharge dampener and an inlet dampener. And Hercules, why don't you talk a little bit about the inlet side, because I know we talked about that before, how important that inlet side is to the pump.
Yeah, indeed. The inlet is how can I say, not focused enough actually when it comes to peristaltic pumps, because the hose has to do all the work when it comes to drawing the product into the pump. Most of the work, because it has to expand from a squeezed position back to the round shape. The hose is quite robust on the discharge side because it's got quite a high burst pressure. I mean, if you look at the wall thickness on these hoses, they're quite robust. The wall thickness is not necessarily designed that thick to prevent bursting. It's more so to help with the rigidity of the hose on the suction side. Most of premature hose failures, probably around 80% of premature hose failures in peristaltic pumps, is due to bad suction conditions. Because it's neglected when it comes to the size of the inlet piping that's installed, the lack of static head pressure applied. So essentially starvation of the peristaltic pump on the inlet or long lengths of inlet piping to the pump is very, very detrimental to the life of the hose. And this is where the inlet stabilizer plays a big role, is to just smooth out the flows and the pulsation shocks that would be experienced by the inlet side of the pump.
Yeah, and as we look at we know on the discharge side, you know what you're seeing because you see the drastic peak to peak. Is it more dangerous on the inlet side or more detrimental to the hose to not have a dampener on like high inlet pressure or low inlet pressure where you want to vacuum?
You would, well, actually on both, because the inlet pressure will be fluctuating from low to very high again. You will experience the shocks. The hose will be experiencing the shocks. So if you can keep the inlet pressure as constant as possible, and not starve the hose of product, that's what you want to experience. The pump wants to experience, and that's how you will ensure that your hose lives what we used to call at least 5 million compressions.
Yeah,
as a general rule of thumb. Yeah.
And we see in the field, you and I both, we see in the field that that's typically the ignored side of the pump.
Exactly.
Yeah, because you see the discharge side and you see the large pulsation swings, but we don't always address the inlet side. And so going forward, it's good to everyone just to pay attention to that inlet side of the pump, and you know, dampeners do increase the hose life, I believe.
For sure.
Yeah.
And as you say, Marcus, on the discharge side, visually you can see the pipes are moving. There's pulsations. There's rocking of the discharge lines moving around. So it's very visual to say, okay, well, there's something going on here. But the hose itself is fine. In that case, it's your system, your downstream piping that's experiencing all the shocks. But on the suction side, when it comes to the hose itself, you need to pay attention to what your inlet conditions are, because you can't visually see this. There won't be any rocking of the inlet piping, and the hose itself will be absorbing most of the loads there.
Awesome. Next slide. I don't have control of it, so good. So just putting it more in an individualistic component side. Of course, you know, we're being a Blacoh dampeners company, so we provide pulsation dampeners for both the inlet and discharge sides, and we go up to currently now with the center section where the pulsation dampeners, our new surge shield, we are currently going up to 8-inch size in hose pumps. So we're pretty much covering the gamut of any size, being if it's just a small little quarter-inch, half-inch dosing type of pump, all the way up to an 8-inch discharge side. We are able to provide dampeners for you on each side. Next slide. Once again, just components. If you have a smaller system where you need a relief valve or a back pressure valve, and then, you know, very important also is our gauge guard. Okay, every plant I go into has two problems. They all have gauges don't work, and these can be prevented because the gauge is typically on a piping system where it's exposed to the process chemicals. We have a gauge icer that separates the process chemical with a diaphragm from the gauge, and so one side is the process side, the other side has a barrier fluid, typically glycerin, and that just keeps your gauges from being exposed to process chemicals. So when you're able to diagnose your system, and you need to say, well, someone asks you what's the gauge is reading, you'll be able to read the gauge. So something to keep in mind when you're looking at components for a hose pump system. Go ahead, next one. So this is kind of back to the slide of where Hercules was showing all the different areas that you can work in with hose pumps and dampeners. You know, it's heavy duty and industrial side. Probably the most, I'm on the West Coast, so probably most of the time we see this in Hercules too in the mining industry. And they're doing some kind of innovative things in the mining industry where they're relying more on hose pumps to pump material. And so we see a lot more use in the mining industry than probably anywhere else. And then, of course, like Hercules said earlier, maybe you could touch on that a little bit on the mining side, because I know it's a big concentration for you guys, what you see.
Yes, it's in the recent years we've seen an uptick in the use of peristaltic pumps. Also for due to the high growing pressure when it comes to reducing the amount of processed water being used in the mining industry. Because the peristaltic pumps, or positive displacement pumps in general, is able to move higher percentage solids than centrifugal pumps. It obviously vastly reduces the amount of processed water being used in the systems in mining. So the environmental pressures being placed on the mining industry has been pushing the need for peristaltic pumps a little bit higher, because of their ability to use less water in the transferring of products. So that's where the mining industry has been seeing a lot of benefit in the capabilities of peristaltic pumps. And with that, obviously, as Markus has mentioned, the nature of positive displacement pumps requires the dampening of those pulsations. And so the two are pretty much a very good synergy for each other when it comes to solving solutions with higher percentage solids applications.
Yeah, and I see a lot in food and beverage also, because like you said, where you get those real thick slurries and real thick sauces, molasses, those kind of things, that's very thick, and they're very easily pumped with the peristaltic pump.
Indeed. Yeah, I mean, the food and beverage industry, I mean, those will be obvious applications where the product being pumped is shear sensitive. Food processing, moving the product with a centrifugal pump will just not be practical due to obviously being shear sensitive and the high viscosity. So positive displacement pumps works a charm in the food industry. And obviously, if they're approved and rubber hoses that's available for the food industry is a big talking point. And there's systems that can be applied to the peristaltic pumps to allow clean in place actions that needs to be administered to the pumps and the lines. Inserts that are food safe, 304 stainless, all of that is available for the food industry. So yeah, the peristaltic pumps do play a good role in that industry for sure.
Okay, great. That's the next slide. I think
Okay.
this is. Yep.
Yeah, this brings us to a bit of the meat and potatoes of pumps and dampeners. How they solve everyday problems that we experience in applications. I'm going to bring this one to the forefront. We've actually been recently involved with where a mine site in northern British Columbia were using vertical tank pumps, vertical centrifugal tank pumps, to transfer sample slurry from the pressure sampler to the analyzing system to analyze the online slurry to see what the process conditions are. And these guys have had some endless headaches with the tank pumps just failing once a month, essentially, due to just the high abrasive nature of the slurry that they were pumping. And for 5 years they've been struggling. So they approached us to see if we can supply a solution. So we put in there a trial pump. It was a 2-inch pump with some suction and discharge dampeners to see if we can resolve these issues. Now, the suction and discharge conditions were of such that we had a very, very long suction length, but also there was a high pressure inlet because the sample line was being fed from a pressure sampler. So it was a positive inlet pressure from a long suction length as well as a long discharge length, 2 pulsation dampeners, running the pump ran at 32 RPM, 2 5-gallon Blacoh dampeners installed. And the results of this installation showed that we were able to more than double the life of before the hose itself then failed as a natural occurrence of a wear item. The hose then failed, almost tripling actually the life now that I look at it. So this is the key takeaway from this situation is that peristaltic pumps' ability to resist high abrasive slurries, as well as the pulsation dampeners that's able to remove these pulsation spikes. That the two of them join forces in ensuring that this problem is solved, and we actually see this more and more now on the even though look at this, the solids percentage, and this was 37%. It's slightly lower, so it could be judged that it's well within the envelope of centrifugal pumps, but just the abrasive nature of the slurry and the operating cost of a centrifugal pump, the peristaltic pump worked more efficiently and with a lower operational cost than the centrifugal pump.
So this is an application that we solved a problem for a customer at a municipal treatment plant, and they were getting. It's very important in the municipal world to in your chem feed to have a consistent flow, right? And they're usually dosing through a flow meter, and the only way to be able to measure that is to have a smooth laminar flow, kind of the curve we looked at, that smooth laminar flow curve where the peaks to peaks are being eliminated. So they were using a very large peristaltic pump, which the larger they are, the larger the pulsation swing. And they were having trouble with that flow, and it was just causing inconsistencies in their mix tank. And it's very hard to, when you're on an operating side, or when you're in the operators, to make adjustments in the field, for these things. These are systems that were put in. So they had to look for, how are we going to make sure that this downstream feed is going to be dosed properly. They called us up and they asked us, what our solution was, and we suggested a pulsation dampener. And so we sized it based off the gallons per revolution. They selected our 5-gallon bladder type epoxy coated dampener. And when the dampener was installed, it quickly smoothed that flow out. So downstream, we had a nice smooth laminar flow. We also had accuracy in the measuring, and they were able to deliver the chemicals they needed to their mix tank accurately.
Yeah, here's another practical application at a chemical manufacturing facility local here to us. We supplied a 3-inch peristaltic pump to an underflow application, very highly corrosive application, highly caustic, and actually, as you can see there, the slurry temperature is 66 degrees Celsius. So it's a bit of a very arduous application. And unfortunately, the client installed the pump, and not adhering to the recommended line sizes, they installed an undersized discharge line. And with an undersized discharge line, which meant that the discharge pressure was quite high, which required the pump to be shimmed quite extensively, compressing that hose to ensure that there's no backflow, because they were pushing almost around 8-9 bar on the discharge. This means you have to compress that hose quite a bit to prevent backflow, and backflow is also quite detrimental to a hose, because as the backflow occurs, as the hose is not able to hold the pressure back, it actually bypasses the roller and it cuts the hose up. So it's quite detrimental as well. So you need to ensure that proper shimming is applied. And in this case, obviously, if you highly shim the hose, there's a lot of load being applied on the hose, and combined with a high product temperature, the life of the hose is quite bad. And the client was not able to change the discharge line to a higher spec, to a larger ID. So the only available option was to actually reduce the pulsation spikes and keep using the same discharge line. So we installed on the suction and discharge pulsation dampeners to bring down the discharge pressure, and which allowed us to remove some of the shimming inside the pump, so have less shims and more gentle squeezing of the hose, less load being applied on the rubber, less stress on the rubber, which meant that the hose is able to survive vastly longer. I think we were able to extend the life of the hose by almost double, just being able to reduce the discharge pressure and smoothing out that discharge flow, and removing some of the shimming being applied onto the hose. So yeah, that's the very practical application of being able to reduce the pressure, reduce the load on the hose, and you're able to extend the life of your hose.
All right. So the guys have gone through quite a number of things over the peristaltic pump basics, where they're used, including the battery, water, wastewater, food, mining, to name a few. We talked about the common components across all peristaltic pump lines, the benefits of a pulsation dampener, and then some real life stories. So I appreciate everybody staying tuned for all of that. We do have one question in the queue here, and it says, what does Blacoh recommend for use when dampening slurries up to 80% solids by weight in a peristaltic pump application? Do you have a dampener suitable for this service where the bladder will not tear, plug, etc.?
You know, Hercules, you, I mean, I have an answer, but why don't you go ahead and see what your experience is? You deal with a lot of solids.
Yes, no, exactly. 80% solids, I mean, is obviously a high number, and it's not a problem as long as the discharge dampener, and obviously Blacoh has this in their range. There's a free flow port. So a lot of dampeners would sometimes have a screen or a poppet plug or a mechanism in the inlet port of the dampener that would restrict flow. It's very important to make sure that that inlet to the dampener is of a free-flowing port, and which means that also that the bladder then needs to have a anti-extrusion bottom, and a thickened bottom or a steel plate. Some of them have fused into the rubber, so it's just ensure that that inlet port to the dampener is clear, and then there shouldn't be any problems with pumping 80% solids with a peristaltic pump and dampener.
Yeah, and I just to add on to that also, like Hercules said, it's very important the nozzle, which is the bottom part of the dampener, hooks onto your piping. That is clear and that is open. I've even used in some environments, we've actually used tri-clamp connections, because the tri-clamp connection is just a wide open connection that offers a large nozzle that's clean and free of any screens or any plugs anyway. So there's no way that stuff can plug up, the solids can plug up. This is also critically important that you have the dampener installed right on the discharge line as close to the pipe as possible, because you don't want anything having to travel a distance and then come out of that distance. So that would be, eliminating any risers is important. We do offer dampeners and bladders with anti-extrusion buttons. We also offer in highly abrasive resistant materials like Hypalon and EPDM. And we've really never had an issue with free flow, because we do a lot of work in slurries and filter presses, and it's just making sure, like Hercules said, that nozzle is free and clear to flow into the dampener, out of the dampener. Any other questions, Jen?
Sorry, I was reading and talking and nobody heard me. We do have another question. It says, what is the recommended pressure to charge the inlet stabilizer to? Is it sized using the revolution gallons like the discharge side?
Yes. Oh, go ahead, Hercules, go ahead.
No, well, that's actually your field, Mark. I'll just speak from experience, just from essentially what is on the Blacoh manual, which recently looks. I think it's 50%. It's a lower value than the discharge side, I think.
Yeah, and I always try to match typically, I think we try to match the dampener, the discharge, and the suction side on a hose pump is the same size ourselves, because that gallon per revolution doesn't change. And then charging is going to be based on what your inlet pressure is. So if you're pumping under vacuum, we have a device, we have a air control that's called a J control that allows you to pull a vacuum on the dampener itself. So you can pull up 4 to 10 inches of mercury on the dampener, or put a positive charge on it based on your inlet pressure if it's positive head coming in. So with the Blacoh dampeners, you have the option of either. So it's all going to depend on how you charge based on what your inlet condition is. Hercules, does that sound fair?
Yeah, definitely.
Yep. Sometimes you have to experiment. If you do have, we do have options. If you do have a airline that's on site that you can hook in, we have options for an automatic inlet stabilizer. But we'd have to, that's something you want to talk to us about. Just email me, call us, and we walk you through the process.
Thank you both, Markus and Hercules. If anybody has any other questions, it's time to quick type it in. Otherwise, we are done with questions in the presentation. Like I said, we will be sending out the PDF version of this to everybody who's registered. So we appreciate your time. We appreciate you attending. And we just got one in. I may have missed this. What is the estimated on the life cycle of the hoses? Example, corrosive chemicals, slurry material. Are these specialized hoses available to be ordered for replacement?
Yes, indeed. The different material options on these hoses there's quite a few options. I mean, you get the standard one, which is just for abrasive use, is natural rubber, but you get for diluted, very versatile one is EPDM for diluted acidic slurries. The more corrosive slurry applications would be Hypalon materials that's available as well. There's even Viton in extreme situations, though Viton would be a last option if no other hose option is suitable, seeing that Viton is not necessarily, doesn't have the greatest mechanical life, so it's only in situations where no other hoses work properly you would use a Viton option. But Hypalon is usually quite corrosive resistant in acidic applications, so yeah, Hypalon is available.
Yeah, and I'll comment. Hypalon, from our standpoint, for the dampener standpoint, is also very, very suitable in those applications, especially with sodium hypochlorite. So,
Markus, we have one here for you. It says, why is back pressure on the discharge side necessary for the dampener to function?
well, like we said before, when we talk about charging, if you, a lot of times, not a lot of times, but some certain situations, you'll see a pump pumping in just into an open tank where there's no back pressure on the system at all. And when you do with a dampener, you have to move the bladder because you have to accept a certain amount of fluid into the dampener for the dampener to work properly. It's displacement. You have a displacement per stroke of your pump, just like you have a displacement per stroke in the hose pump every time. We call it gallons per revolution, but that's a displacement. You need to have that displacement to go into the dampener, and then that goes into the bladder, and the bladder will push up against the compressed air nitrogen, and that will create the dampening effect. If you don't have any back pressure on the dampener, and you're not getting enough displacement in the dampener, it might not function the way you want it to. For better dampening, we suggest more back pressure. At least with elastomer, anywhere from 15 to 20 psi. With Teflon, you'd want at least 20 psi of back pressure to get the optimal dampening effect. Not saying it won't work at lower pressures, but the optimal effect is to have a little more back pressure than not.
All right. Hercules, we have another one that came in. I think this one's for you. At what discharge pressure would reverse flow into the hose pump be a risk?
I mean, you can, when you're looking at what the hose is able to withstand in terms of backflow at around 2 bar, essentially. If you have a 2 bar backflow, I mean, if you look at taking 2 bar and putting that through the cheek of the hose where the roller is squeezing, even 2 bar could cause some damage to the hose. So it's any form of high pressure backflow would cause impact on the life of the hose, because the first place where the backflow occurs is in the cheeks and the squeeze point of the hose where the shoe or the roller squeezes onto the rubber, and any amount of small backflow there is like a water jet that cuts through the rubber. So shimming of a hose pump is quite important, and to ensure that there's no backflow that occurs. So it's a balancing game. You don't want to over shim because you're going to be reducing the life of the hose, but under shimming is also not good because you'll be seeing high pressure backflow that could cut up the cheeks of the hose. So it is an aspect that gets neglected too often. To apply the formula that's that's given to the operators to ensure that the correct shimming is applied. It needs to be definitely, there's a nice balancing act that you have to apply.
Okay. I think you have answered all our questions, which is great. We got so many that came in. I appreciate everybody's engagement and involvement. That's what we're here for. And like I said earlier, if you're looking for PE credits, your certificate of attendance will be emailed to you. Markus and Hercules, thank you again for your expertise and making this such a great webinar. Everybody have a great day, and we look for us to come back again soon.
Thank you, everybody.
Thank everybody for attending. Appreciate the option and to be able to give you guys this presentation.